So here's a bunch of review problems, some highlights from the review problems that I wanted to discuss before your exam this Wednesday. Now this one will be phrased like this. For each question, write an equivalent quadratic equation that will be easier to solve. Do not solve the equation. So here's the first one. Now, if you were stuck doing this at home or someplace and you wanted to make your life a little bit easier, one thing to note is that all of these have a common factor. And it might be a good idea to divide everything by that common factor so that we can make our problem a little bit easier to work with. Does anyone see a number that goes into all three of these?
6.
6? Do I hear anything higher than 6?
12.
12? 12 will work. Now, if you did 6, then what you'd see is that, oh, well, I can do it again with 2. But let's just do 12 right to start with. And let's see what that gives me. That gives me 5x squared plus 4x minus 3 equals 0. And on WebAssign, you just type in the 5 here, the 12, or excuse me, the 4 here, and it's already got the 3 there for you. So great, great. Let's take a look at another one, kind of like that. 1/8 m squared minus 1/3 m minus 1/8 equals 0. So kind of like the last one, I want to rearrange this one. And the idea would be to multiply everything through by the lowest common denominator. So the question is, what's the LCD for something like this?
24.
Excellent, 24. So what I'll do is I'll multiply everything through by 24. So it's going to be 24 times this, 24 times this, 24 times this, and 24 times this. Now 24 times 0, that's fine. I'm just going to leave that alone. But over here, just for convenience and to maybe help you keep things straight, let's write it as 24 over 1. The only reason I do that is to encourage you to do the cancellation here. 8 goes into 24 3 times. 3 goes into 24 8 times. And then over here again. So what we'll end up with is 3m squared minus 8m minus 3. And can someone do the right-hand side for me?
Just a 0?
Yeah, thank you. Just a 0. Thank you. Awesome. So that would be your answer here. And I think you only need to type in the 3 and the 8, or the 3 and the -8. And that should be it. Now I'll do kind of like a follow-up, one bonus one like that. And we'll actually go a little bit further to solve it with the quadratic formula. And that would be this one. 0.011 x squared minus 0.09 x plus 0.023 equals 0. Kind of similar to the previous two problems in as much as you want to get rid of the decimals this time. We don't have fractions, we don't have numbers that are kind of big with common factors, we've got decimals. So if you look at it, I need to move this decimal 3 places to the right. And this one I only need 2, but this one I need 3 again. In general, I'm going to need to move the decimal 3 places to the right. What number can I multiply by that's going to do that?
1,000?
1,000.
Yeah, a 1 followed by 3 zeros to move it 3 places. Now, again, 1,000 times 0, that's fine. That's just 0.
Hello.
Where you have to be a little bit careful is the middle term. What do I get in the middle term?
90?
Yeah, minus 90x plus 23 equals 0. Now, one of the problems that you're going to see on the exam asks you to just tell WebAssign what are the coefficients you're going to put in to the quadratic formula. So it'd be 11, negative 90, and 23. Not exactly user-friendly numbers. That's okay. Now, I think you've probably seen me do this a few times before, and here it is again. When I fill in the quadratic formula, what I'll typically do is I'll write a bunch of empty parentheses and then go back and fill in the parentheses. So we'll start out with negative b. So that'd be the negative of negative 90. And then negative 90 squared minus 4 times a times c. So 4 times 11 times c, which is 23, over 2 times 11. So, okay. Double negative here gives me a 90 plus or minus the square root of 8100 minus 44 times 23 is 1012 over 22, or 90 plus or minus the square root of 7088 over 22. Not exactly a user-friendly number. So, okay. Let's see if we can't get some decimal values out of that. And I'll show you how to do it on a graphing calculator. So let me cut over to that. So here we go. Now, if you've got a TI-83, it's going to look a little bit different. You have to be a little bit more careful. But in any case, probably the most general, easy way to do this is start out with a left parenthesis, then 90, plus the square root. So you hit the second key, then the squared key, square root. Now for a TI-83, it's going to put in this left parenthesis. I'll go back and show what it looks like for those of you who don't have a TI-83, if you have a TI-84. 7,088. Now with the 83, you close off the square root here by using a right parenthesis. You need another right parenthesis to finish closing off the numerator. You don't have that problem with the 84. 84 is just a little bit more user-friendly. Divided by 22. And there you go. About 7.92, we'll call it. You're rounding to the nearest hundredth. Of course, I prefer the nearest thousandth, so it'd be 7.918. So I'll tell you what, I'll do it 7.918. But now I need to see the negative case in this. If you've already typed in the positive case, I would just go back and highlight this, press enter. It should bring it down here so that you can just quickly change that to the negative case.
I have a question.
Yes.
If I was plugging it into the, because I usually use the Desmos scientific calculator, would I be able to plug it in the exact same way? Or would it be a little
You
different?
should be able to. Now let me finish showing this here, and then we'll look at it on Desmos real quick.
Okay.
So let me clear all this. And you know what, we're gonna reset the mode. So now it looks like the 84 that most of you are more comfortable with. All right, so parentheses, 90 plus square root. So this is all looking the same so far. 7,088. Whoops. What happened there? 7088. Now you don't have to put in a right parentheses, but you do have to hit the right arrow to get out from underneath the square root. That's what it tells it. Okay, you're going to take the square root of this number. Close parentheses divided by 22. And then you can go back here to get, say, the negative root by simply changing that plus to a minus. And let's take a look at it on Desmos. You're right that you probably want to go to Desmos.
Talked about the planet part.
Not you. So if you go to Desmos.com and click scientific, you'll get a graphing calculator. And let's see. I'm done with the contrast there. If I wanted to calculate this on Desmos, let's see, I need to get on a new line by itself. Where's the parentheses? Oh, here we go. So it would be parenthesis 90 plus square root. Oops, I don't want 2 square roots, I want 1 square root. Square root of 7,088. Well, what's going on here? Um, 7,088, and then close parenthesis, divide by 22. So you're getting the same thing. So whatever works for you, as far as coming up with numerical values for that, that's fine. Let's see, can I go back up here and edit that? Let's see, probably can, to get the negative solution. There you go, 0.264. Does that help?
Yes, thank you.
Good deal, good deal. All right, let's do some other ones from your review. And this one in particular, I kind of really liked. At first, I'm like, nah, it's asking too much. But then I looked at it closer and I realized, oh, this has got something that's really actually pretty clever. So let's see and understand this. So on the one hand, I got x plus the 6 times the square root of x minus 16 equals 0. And let me get on the screen there. And on the other hand, I've got x to the 2/3 plus 6x to the 1/3 minus 16 equals 0. Now, in this form, you may not really recognize it as being quadratic in form. But let me rewrite this. Instead of the square root of x, I could write this as x to what power? Any suggestions?
1/2.
Yeah, x to the 1/2 power. And even though it's not written, what exponent is understood to be out here?
1.
A 1. So if you look at this exponent is half of this one. That makes it quadratic in form. So I can solve this by doing a little substitution. I can let u equal what here?
X to the 1/2 power.
Excellent. Thank you, Z. X to the 1/2 power. And so that allows me to write my equation like this. U squared plus 6u minus 16 equals 0. And that's a little bit more user-friendly. I'm guessing that there's a few of you out there that could probably factor this. Prove me right.
8 and -2.
Good.
8 plus 8, u -2.
Nice. That sounded like Christy. Thank you, Christy. What does it give me for solutions then?
8 and -2.
-8 and 2.
-8 and 2. Now that's great, but those are solutions for you. This original problem started out in X, so I need to go back and figure out what that could be. So I get X to say the 1/2 equals -8, and X to the 1/2 equals 2. So I'm not done yet because I don't have X by itself. But there was a trick that I suggested in the videos. So who was watching it? Who picked that up?
Multiply by the reciprocal of the x.
Yep.
Excellent. You want to raise both of these to the reciprocal power. So I'm going to square both of them. And that makes sense because really X to the 1/2 power is a square root, right? So what I'm effectively doing is squaring a square root. These are inverse operations. And then when that cancels, that leaves me with X equals 64. Or over here, what do I get for X?
4, right?
Yep, X equals 4. Except there's a little bit of a problem here. And I'll talk about that in a minute. But are we okay up to here?
Yeah.
All right. So I'm going to come back to this one. But here's what I like about this problem. Because remember, there's actually 2 problems side by side. Now over here, this is quadratic and form again, right? Because, well, half of this is this. Half of 2/3 is 1/3. So this is quadratic in form. What would I make my substitution? What would I let u equal?
X to the 1/3.
Beautiful. X to the 1/3. Exactly that middle term. And I like that you nailed it. You're not dealing with the coefficient, you're dealing with that. But the interesting news is that you get u squared plus 6u minus 16 equals 0. Do I need to solve that all the way through again? Or can I just say, oh, let's jump to the happy ending, and I know that it's going to be u equals -8 and u equals 2. In fact, you could just jump from here down to here. That'd be fine. Because it's the same equation, has the same solutions. What's different is that when I get down to this part, u is taking place of x to the 1/3. Now, how do I solve here? How do I finish solving this?
You gotta raise it to the 3rd power?
Yeah, nice. Well done. So the reciprocal of 1/3 is 3. So if I cube both sides, if I cube both sides, then I should get x. 3 times 1/3 is x to the 1st power. -8 cubed is -512. And then 3 times 1/3, oh, that's x to the 1st power again. You know what? I'm just going to write x. 2 cubed is 8. So I get 2 solutions here. So it's raising both sides to reciprocal power. It works great. I get 2 solutions here, but I only get 1 solution here. Wow. Well, why do I only get 1 solution?
64 doesn't check, right?
Right, that the
Exactly.
-8, yeah.
Extraneous.
Wow, you girls are rocking. You're making me look good. Bonus points. Yeah, because if you try checking it, you know, let's look back up here. That's really the square root of 64, or square root of x, in this case 64, but that doesn't equal -8. So we have to throw that solution out. That's an extraneous solution. Now, if I do take the square root of 4, square root of 4 will give me 2. Square root of 4 is 2. That one works, but this one doesn't. You're only going to have that problem with even roots. With odd roots, like a cube root, which is what this is, that's not a problem. When I put this back in, the cube root of negative 512 is negative 8. That checks. Cube root of 8 is 2. That checks. So both of these will check, and they're going to check in odd roots. Got to be a little bit careful with the even roots, though. This idea of raising both sides to reciprocal power is really powerful. Let me give you one last one kind of like this. In fact, using the same numbers, just a different exponent. If I had, for instance, x to the negative second plus 6x to the negative first minus 16 equals 0, can't we play the same game?
Yep.
What would u equal in this case?
X to the negative 1.
X to the negative 1. And that would give me u squared minus, or excuse me, plus 6u minus 16 equals 0. And we already know that, what the solutions are for this, right? We've all done this twice now. We got u equals negative 8 and u equals 2. Those were our two solutions to that equation. The difference this time is instead of something to 1/2 power or something 1/3 power, I've got x to the negative first power. So how do I deal with this? Same way that I dealt with the other two. Raise both sides to the reciprocal power. The weird thing about this one is what the reciprocal power is. The reciprocal of negative 1, if I do 1 over negative 1, is negative 1. It's its own reciprocal, which is kind of strange. There's two numbers that are their own reciprocals. 1 and negative 1 are both their own reciprocals. Negative 1 times 1 gives me x. Negative 1 times 1 gives me x. 2 to the negative first power, that's 1/2. Reciprocal of that gives me negative 1 over 8. And that's it. All right, so those are all the different varieties of problems you can face when you're doing those quadratic substitutions. Put things that are quadratic in form into proper form and solve. Any comments or thoughts before I move on from this one to other examples? Going once, twice, sold to the A student. Parabolas. You should be able to graph these things. And in particular, you should be able to tell me what the vertex is and the axis of symmetry. So let me copy this one down here. F of x is x minus 3 squared. Was it plus 8? It was plus 8, wasn't it? Yep, plus 8. Plus 8. So I'm going to do things on a little t-table here. And I'm going to put the vertex kind of in the middle. You should be able to read off the vertex. What would the vertex be?
3 and 8, or 3, 8.
3 and 8. You start by making the squared term equal to 0. If I put in x equals 3, 3 minus 3 is 0. Squared is still 0. 0 plus 8 is 8. So 3 and 8. When you graph this on WebAssign, though, you're going to need 2 points. So this one and one next to it. Now, we ran into this problem before with graphing these things. Sometimes it's nice to put the y-intercept. So that means plotting x equal to 0. But if I did that, if I put in a 0, I end up with 17. And that's taller than my graph, probably. Yeah, well, not in this case. No, they actually do have enough room there. My bad. But if it does end up being taller than your graph, you want to choose something that's closer to your vertex. And so there's two good choices. You could choose x equal 2 or x equal 4. Both of those are close to your vertex. The easier one would be 4. 4 minus 3 is 1. 1 squared is still 1. Plus 8 is 9. And if you plug in 2, you'll also get a 9. So plot 2 points. I think that's all you need to graph these things in Desmos. I mean, not Desmos, but WebAssign. There is one other feature of this graph that you should be aware of. It's a parabola in shape. It has a vertex at 3 and 8. The other feature that you should be aware of is this line. What's that line called?
The axis of symmetry.
Axis of symmetry. Now, it's not really part of the graph, but I'm drawing this just to help you see that it's a vertical line, so it has the form x equals something, and that x is going to be equal to 3. That's going to give you the vertical equation of your vertical asymptote. That was redundant. That's going to give you the equation of your vertical asymptote. Be careful not just to type in a 3. If you type in a 3, they'll mark it wrong. It needs to be x equals 3. They're looking for an equation. Hopefully you can see that right here. Right there, x equals 3. All right. How are we looking there? Okay. Let's continue with this one. This is some function notation stuff. I think this is from section 11.1. So they give you f of x is 6x plus 1, and g of x is x minus 7. Now, again, this is something that you're going to struggle with if you're trying to use, something outside of what we've done in class to help you out with this. They're not going to know what to do. The problem is going to ask you to find f divided by g of x, which in other word notation would be f of x divided by g of x. And then also to figure out its domain. Well, okay. F of x is 6x plus 1. G of x is x minus 7. Looks good. So you got the first part right. For the domain is going to ask you to basically figure out, well, what value of x can't I use? And then throw that out of your domain. There's only going to be one value of x that's going to create a problem in this function. Does anyone see what that value of x is going to be that creates a problem?
Positive 7.
Positive 7. Well done. Thank you, Courtney. So if you had a 7 here, 7 minus 7 would be 0. You'd be dividing something by 0. You can't do that in math. We just don't allow it. So x can't equal 7. Now, unfortunately, WebAssign is going to want interval notation for that. So basically, we want everything except 7. That would mean negative infinity to 7, and then 7 to infinity. Everyone but him.
I have a question real quick.
Yeah.
Do we use the union sign in this example or do we not?
So the way that they have things here, you're using the union symbol. Yeah, I would suggest you would use that, but you should be able to get that off the palette that you use to enter your answers in. Does that answer your question, Courtney?
Yeah, I just wanted to double check because I know I was doing a homework assignment before and it was marking it wrong when I was using the union sign.
You should be able to get it right if you're using the union symbol and have the right answers. I don't see anything wrong with that. Now, I did a different problem than what the book had here or what WebAssign had here, but it's still the same kind of thing. You have to figure out where this could equal 0. This equals 0 and x equals -1/6. So this is basically everything except -1/6.
Okay, cool.
Thank you. Let's move on to functions and graphs. Let me get rid of some miscellaneous information here. Now, this is another good problem that technology is not going to bail you out. You're going to have to know what you're doing here. It's not hard, though. Let's start by understanding some of the notation here. They give you some graphs. They give you a graph for f of x, g of x, and they ask, for instance, to find f plus g of -5. So do yourself a favor and unravel this and write it like this. Oh, that's really f of -5 plus g of -5. And now that we've kind of split it up a little bit, now we can look for those values. So I'll start by trying to find f of -5. So you go out the x-axis, find -5, and up at the equation, -5 is right here. What's the value? What should I put in for f of -5?
Should be 3.
3. 3 plus, and now we got to figure out what happens for g of -5. So for g of -5, instead of going up here to this graph, I'll go down here to this graph. G of -5 would equal what?
-3.
-3. Perfect. And that's it. That's it. I did have somebody in my morning class that was struggling a little bit with one of the other problems. And I'm not sure exactly what could have been the problem, but it could have been something like part C here. And the thing you have to be careful about is the symbol between these two things. That's a times. So that really means f of -2 times g of -2. So f of -2 times g of -2. Now you're looking to figure out what each of these are. So let me put that in, say, blue. F of -2, well, go out the x-axis till you get to -2, and well, the function is right on the x-axis at that point. So what's f of -2? Let me see if I can't make this bigger. F of -2 is 0. Thank you. How about g of -2? What's g of -2 going to equal?
-3.
-3. Perfect. But did it really matter what g of -2 was? Not really, because you're multiplying. It'd be 0 times -3 is still 0. Okay, cool.
I have a question.
Yeah, please.
Would you be able to do an example with the composition one, like f of g
F
of
of G.
x?
Yeah, funny thing is, I was heading right there because the mistake my student made this morning could have been confusing this notation with this notation. And I've tried to accentuate this a little bit, just so you can see the difference between a times and a function composition. This means something entirely different. This would mean f of g of -2. Now, I don't know as though this one's going to work out nice and even and perfect, but we'll do our best. Let's take a look here. In doing this one, the trick is to start with the inside part of this, which would be g of -2. Okay, so g of -2, let's see what that is. Well, I guess we kind of already got that, right? What's g of -2?
-3.
-3. So the idea is to replace this g of -2 with a -3. We good with that? We did this. We said, okay, g of -2, that's -3. They're interchangeable. So now I'll look at the rule for f, or the graph for f, and try and figure out, well, what's f of -3? Dorina, what's f of -3 going to be for me?
That would be 1.
Yep, that would be 1. Because when you go out to -3 on the x-axis, then up meet the function, its y height is 1. So there we go. Is that what you're looking for?
Yeah, it was. When I was doing the homework, those were the questions that I figured them out, but I just wanted to recap on them because those are the ones that were the most.
No, that's great. Let's think. We could also do g of f of -2. Now, if I get the same thing, that means the order is commutative, or these functions are commutative. This operation is commutative. But generally speaking, I don't get the same things. Now, the difference in this is what's on the outside. Which function's on the outside with this one?
G.
G. So it's going to be g of f of -2. We've already done f of -2 up here. F of -2 was 0. So I'm going to kind of cheat a little bit and say, oh, well, that's just g of 0. See if you can't find g of 0 for me. What's g of 0?
-1.
Yeah, -1. Thank you. -1. It's just the y-intercept, right? You find x equals 0, go to the graph, you're finding the y-intercept. So the order makes a difference. Those two things are completely different animals. Okay, I'm hoping that helps out with some of this function notation and function composition. Anything else while I'm here? Let's keep going. Let's see. You know what? Let's do this one quick, and then I'll make one more quick remark and we'll get you out of here. So f of x equals 3x minus 6, and f inverse of x equals x plus 6 over 3. Now there's one like this in the preview. I kind of like it, which is why I want to discuss it here. And they ask you to calculate this a couple ways. They ask you to calculate f of f inverse of x. And what that really works out to is this. Now in the WebAssign homeworks and preview that you're going to look at, it'll run you through the problem like this. It'll say, all right, well, start out by giving me f of something. What you have to realize is they want you to replace f inverse of x. Well, that's that whole expression there. So I'll put that in, I'll do it in red, x plus 6 over 3. The next thing they're going to give you is the rule for f. The rule for f says take 3 times x minus 6. Well, I don't have an x here. I've got a 6 or x plus 6 over 3. So all that stuff is going to be put right here. Now, I don't think that they're going to do this next step, but I'll put it in just because I think it helped a few people in one of my classes. I'm going to write that 3 as being over 1. And the reason I'm doing that is because I want to encourage you to do some simplification. You can't cancel the 3 into the 6 because this is one whole term here. So kind of think of that in parentheses. You can't cancel into a parentheses. But when there's multiplication, you can cancel. And so the next thing you'll see in WebAssign is x plus 6 minus 6. And that simplifies to just x. Now, if you did things the other way, if you did f inverse composed with f of x, you'll end up with the same thing. You'll end up with x. So that's only going to happen when you have a function and its inverse, that you'll end up with x either way. All right, last one. I like these problems, but there's not much work you can show for it in terms of writing things on a paper. And please be careful in showing me your work. I get uncomfortable, like I said, when there's the right answer but the wrong work. So for this last one, g of x is x to the, or 4 to the x minus 1 over plus 7. I'm not sure if I'll be able to figure it out in time for the exam, but if I can, heads up for it. What I might do is ask you to describe the shift. And maybe I'll give you a bunch of options. What does the x minus 1 here in the exponent do? How does that shift the graph compared to, say, f of x equals 4 to the x?
Goes right 1 and up 7.
Yeah, right 1 and up 7. Beautiful. Now you can probably figure that out by just looking at, you know, a graph on Desmos. So what I could do is make it a little bit more challenging to graph this to the point that you just got to know what's going on. So I could do 3 to the x minus or x plus 2021 minus 8,192. Wow. Good luck getting that to show up on a graph. But the ideas still stay the same here. We can figure out how this has been shifted. So what do you think?
Left by 2021 and then down by 8,192.
Perfect. So since I got a plus here, that's a horizontal shift to the left by 2021, and then down 8,192. Beautiful. Okay. Sorry we ran a little bit extra, but I think it was time well spent. Any last minute comments, thoughts, hints, or suggestions?
Hi, I hate to bother you.
Go ahead.
Are we able to have that discussion about the series?
About what to take next?
Yes.
Okay. Let me make sure I got all any questions about the test first and the review that I just did. All right. I'll pause the recording here and then we can discuss that. So thank you.